Hi everyone, this video is about the permutations and combinations. P stands for permutations and C stands for combinations. Each of them can be sampling with replacement or without replacement. So what's the difference between this and how we can calculate? For example, when we have permutation with replacement, we show it with P of nk, PR of nnk, and without replacement, it's P of n choose k. And then we have combinations with and without replacement. Combination, again, C stands for combination with replacement, N choose K, and combination of N choose K. Okay, when we have permutations with a replacement or P of R, N, and K, there are K different distinguishable objects, and for each position there is n different possibilities, so the permutation gives us n to k. But if we have permutation without replacement, then during the sampling without the replacement, the number of possible sections reduced by 1 each time. So P of n choose k, actually it's not n for each time. The first time is n, second time is n minus 1, and so on. If there are k different outcomes, then the last one is n minus k plus 1, and it's equals to n factorial over n minus k factorial. If we don't have permutations, and when we are choosing, it's just a combination, and we have k indistinguishable objects, then we use combination. Combination also can be with or without replacement. Most of the time we have combination without replacement, that we show it with C of n choose k, or maybe you see it as n choose k like this, and s equals to n factorial divided by k factorial times n minus k factorial. What is the difference between permutation and combination when we have n choose k? As you see, the formula is pretty similar to each other. The only difference is in the denominator. Both of these, permutation and combination, it's without replacement, so you don't see any R here. But combination here, the order is not important, because order it's not important for the similar items. For example, if you think about 3 green marbles, I'm going to label them just for you, not in general. They don't have label. Let's think this is 1, 2, and third. And there's no difference if I change the position of 1 and 3. Now 3 is here, 1 is here, and 2 stays in the position 2. When you look at the outcome, what is the outcome? Actually, you see this as outcome. This is one outcome, and this is the second outcome. When you look at these two outcomes, they are exactly the same. If I tell you, if I tell you this one is green, this one is red, this one is blue, what is the permutation of this? What are the all possibilities? Your answer is 3 factorial because they are different. But right now, when you change their position, the permutation gives you the same outcome. So we have k factorial in the denominator because of that. Now I want to go over some questions, permutations and combinations. The question says you need to arrange 7 books along the bookshelf, assuming that the order of the books makes a difference to you. How many different ways can you arrange the books? Okay, we have bookshelf, okay, and we have 7 different books. Also, the question says the order makes a difference. So order is important. Because order is important, we deal with permutations. And because we have 7 different books, we want to put them in bookshelf. It cannot be with a replacement. We have 7 different positions. Okay, and if I put the, for example, history book here, at the same time I cannot put the history book here or here. If I put it here in the first position, it stay here, and then the rest positions belongs to the other books, right? So it's without replacement. So how we approach? For the first position, actually, there are 7 different possibilities because we have 7 different books. We put one of them in the first place, right? For the second one, right now we have 6 different books, 6 different possibilities. And then for the next one less, right? And we continue. If I want to go over the formula, we have permutation without replacement, so no R. And then how many books are there? Overall 7. And we are choosing 7 of them, right? Because we want to put all the books in the bookshelf, not some part of. For example, I didn't mention that in the bookshelf, I want to put 3 from these 7. I mentioned we have 7 books. We want to arrange them in the bookshelf. So n is 7 and also k is 7. What was the formula? The formula was n factorial divided by n minus k factorial. 7 minus 7 factorial. So it's 7 factorial divided by 0 factorial. The value of 0 factorial is 1, right? And numerator is 7 factorial. So overall, the final answer is 7 factorial. If you go this way or this way, because here also you see 7 times 6 times 5, 4, 3, 2, 1, we have the same answer, 7 factorial. The next question says that you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can those offices be filled? So we have overall 20 different choices. Among all of them, here the order is important because it's important that, for example, your friend A be CEO or he or she be operating manager or another position, right? So the position is matter. So it's important. So we have permutation because the order is important here. Now the question is, this permutation is with replacement or without? If someone is chosen for CEO position, it cannot be operating manager at the same time. So it's without replacement. So we have permutation, and without replacement, we are going to choose 3 from overall 20. Why 20? Because it says you and 19 of your friends. So n, or overall, it's 20, and then we are going to choose 3. So permutation 20, choose 3. It's equals to n factorial divide by n minus k factorial, 20 minus 3 factorial. So 20 factorial divided by 17 factorial. How we simplify? You write 20 factorial. You can rewrite it as 20 times 19 times 80 times 17 factorial, and denominator is 17 factorial. Simply, you can divide numerator and denominator by 17 factorial because it's non-zero, and then you multiply 20, 19, 80, and the final answer here is 68 for the different possible way. Next question. There are 20 computers in a store. Among them, 15 are brand new and 5 are refurbished. 6 computers are purchased for a student lab and they are selected at random. Compute the probability that among the chosen computers, 2 are refurbished. So what is given here? Let's look at the question. Overall, we have 20 different computers. 20 computers in a store. Actually, I shouldn't say different. We have 20 computers in a store. They are similar to each other. 15 out of 20, we have 20. 15 are brand new and 5 are refurbished. And 6 computers are purchased. Among 20, 6 are purchased. And they are selected randomly. So there's nothing specific behind the computers. All of them are pretty the same. And we choose 6 of them randomly. Now we are looking for the probability that 2 of them are from the refurbished. If among the 6 computers, 2 of them are refurbished, then how many of them are new? 4 of them should be new one. The question here is, should I use combination or permutation? When we choose 6 computers out of 20, order is not important. So we deal with combination first of all. If we choose one of them, can I choose it again? No. So it's without replacement, right? It's without replacement. So I'm choosing overall, in total, I'm choosing 6 out of 20, or choose 20 from 6. Okay, so the total is this combination of 20, choose 6. This is my sample space. This is the size of sample space. How we can calculate the combination of 20 and 6? You remember that the formula for n choose k combination is n factorial 20 factorial divide by k factorial times n minus k factorial. So we have 20 factorial, 6 factorial, and 14 factorial. Now, what we have? Our favorable event is to have 2 refurbished and 4 brand new. 4 brand new and 2 refurbished. So my favorable is to have 2 refurbished and 4 brand new. How can I count them? Actually, this is again combination, right? I have combination of out of 15 brand new. I'm going to choose 4 of them, and among the 5 refurbished, I'm going to choose 2 of them. And then probability is the size of event E divided by size of the sample space. So I can write it as the probability of E here. It's norm of E divided by norm of omega. So we have first one is 15 factorial, 4 factorial times 15 minus 4, which is 11 factorial. And second one is 5 factorial, 2 factorial times 5 minus 2, which is 3 factorial. And denominator, again, it's 20 factorial, 6 factorial, and 14 factorial. Now you need to do the simplification and find the final answer for the finding the probability. And the question was about 20 computers, 15 brand new, 5 refurbished, and we are looking for the probability of having 2 refurbished. The next question is pretty similar to the previous one. Out of 6 computer chips, 2 are defective. If 2 chips are randomly chosen for testing, and it says without a replacement, what's the probability that both are defective? Again, we have 6 computer chips, and among them 2 are defective and 4 not defective. So we are going to choose 2 of them randomly. So among the 6, we are choosing 2, and we are looking for the probability that both are defective. So because we are looking for the probability of event, then I'm looking for the size of E and size of sample space. Because we are choosing randomly without replacement, computer chips are the same. So I have combination and not permutations. So here in the denominator, I have combinations. Overall, I have 6 and I want to choose 2. So the total here is 6 factorial, 2 factorial, 6 minus 2, which is 4 factorial. What about the numerator? What is our favorable event? Among the 6 computer chips, 2 are defective, and we are choosing 2. And also our favorable event is both are defective. So if I choose these 2, it means that I'm going to not choose any from the not defective one. So 0 from here, 2 from here, 2 out of 2 and 0 out of 4. And again, it's not permutation because the order is not important. And I used combination again. We have combination of 2 out of 2, and also the second one is combination 0 out of 4. 2 out of 2, it's 1, right? You can calculate it's 2 factorial over 2 factorial times 2 minus 2, which is 0 factorial, and 4 choose 0 is 4 factorial, 0 factorial, 4 minus 0, which is 4 factorial. And you know that combination of n choose n is 1. Combination of n choose 0 again is 1. And if you simplify, 0 factorial is 1. You can cancel 2 factorial with 2 factorial. The final answer is 1. And also here, again, is 1. So numerator is 1, denominator you can compute and find the final answer. Next question asks us how many arrangements of the letter or the words apple can be make. Okay, when we look at the word apple, we see there are 5 letters. Among the letters, we see A just one time. There are 2 P and 1 L, 1 letter E. When we are writing and making a word, the position and the order, it is important for us. When we are writing a word, the position is important for us. So we deal with permutation. It's with replacement or without. It depends. If it was a general question, probably was with replacement. But here we have this 5 letters and I want to put them here in some specific arrangement. So if I put A here, I'm not allowed to use it here again. So it's without replacement. Okay, overall there are 5 letters, right? And if I want to put them in order, here I have 5 choices, 4, 3, 2, 1. But among all possibilities, all choices, here you see P is repeated. Now, if I pick this P, put it in the second position instead of Third, again, we have the word apple, and there's no difference between the new apple and this apple, right? Basically, when we have n different objects, but among all these n objects, some of them belongs to one category and they are pretty similar to each other. For example, if I have um, five marbles, two of them are pink and one is green and two are purple. Do you think it's the same if I ask you how many possibilities are for the arrangement? Do you think it's the same if I ask you, um, I have one pink, one purple, one green, and one blue, one orange? Do you think I can arrange these and these the same? The possibility are the same? Definitely not, because here these five marbles are different. So I can arrange them 5 factorial ways. But when we have two pink, two purple, and one green, overall, yes, we have 5 factorial. But because we have two pink, and if we change their position, the outcome is not different. Here we have 2 factorial for pink one and 2 factorial for the permutation of the purple one that doesn't change the outcome. So I'm going to remove 2 factorial permutation of pink and 2 factorial for the purple. But for the green, it's just 1 factorial and 1 factorial is 1. So what is the final possibilities for this case is 5 factorial divided by 2 factorial, 2 factorial, 1 factorial. But for 5 different marbles, it's just 5 factorial. The same theory here. I have 5 letters. My expectation is to have permutation 5 factorial. But then I see there are 2p and they are the same. So I need to remove 2 factorial permutation of p1 and p2 with each other. But for the rest of them, A, it's just 1 factorial, P 2 factorial, L 1 factorial, and E is 1 factorial. So 5 factorial divided by 2 factorial, or if you simplify, you get 60. This is the final answer. The next question, in a bag, there are 4 marbles. In how many ways can we select a group of 2 marbles without replacement? Okay, actually we have combination because the order, it's not important. We want to pick 2. And overall there are 4 and we are choosing 2. So what's the formula? You can write it this way as well. And it's n factorial, k factorial, n minus k factorial, which is 4 factorial, 2 factorial, 4 minus 2, 2 factorial. And if you simplify, you get 6 as final answer. But next part asks us with replacement. Again, I have combination because order is not important, but it's with replacement. 4 choose 2. How we can calculate this one? We have combination with replacement. And if you remember, what was the formula? When we have combination and choose k, it was k plus n minus 1, or k plus n minus 1 factorial, k factorial, and their difference, k plus n minus 1, k plus n minus 1 minus k factorial. Then these two cancel out, and n minus 1 factorial is the remaining part. So right now, I want to find the combination with replacement 4 choose 2, so I can show it with this. Basically, we are choosing 2, right? But what is here? What is here? It's k plus n minus 1. 2 plus 4 minus 1, which is 5. And then you just calculate. So it's 5 factorial, 2 factorial, and their difference 3 factorial. If you simplify, you get 10, and you see what is the difference with replacement and without replacement. The next question, there are 5 kinds of frozen yogurt: banana, chocolate, lemon, strawberry, and vanilla. You can have 3 scoops. What number of varieties will there be? And it says order of 3 flavors not important. Actually, it makes sense, right? We want 3 scoops, but it doesn't matter which one is on top of the other one, right? So what do you think? Is it a combination or permutations? If you think about that, those 3 scoops, the shape, you can guess that the order is not important. Overall, I have 3 scoops, and it can be anything that I ordered, right? So the order is not important. So we have combination, and it can be with replacement. Maybe I want those 3 scoops be banana, and my friend wants 2 scoops of strawberry and 1 vanilla. You see? So it's with replacement. So we have combination. N choose K with replacement. What is N? What is K? N is 5 and K is 3 because we want to choose 3. So we have combination with replacement, 5 choose 3. What was the formula? We had K plus N minus 1 and K. So we have 3 out of 7. And the formula is 7 factorial, 3 factorial, 7 minus 3, which is 4 factorial. And if you simplify, you get 35 different possibilities as final answer. Okay, that's all about the combination and permutation with and without replacement. I hope you get the materials.